Hi everyone, welcome to Network Gigs. My name is Sukhbir Chahal and I'm CCI certified. So here I'm launching the CCNP ENCOR course. Okay, so this is the first video of the course, and I'm going to discuss about static routing or why we need routing in this video. So here you can see the PDF. So in this PDF, I have topology, and here I have explained about the component and the network devices. So I have one router R1 which have F0 by 0 interface with 10.1.1.10/24 IP, and F0 by 1 is with this IP address 10.1 to 10/24, and LAN 1 have user 10.1 and 10.2. okay, 10.1.1 10.1.1.2, and LAN 2 have user 10.1.2.1 and 10.1.2.2. So if you talk about, if we are trying to communicate this user to this user in LAN 2, so user 1 will forward traffic to the gateway router, which is R1, right? And as we know, router have all network informations by default in routing table. Those are directly connected. So R1 have two directly connected network here, 10.1.1.10/24, which is directly connected with F0 by 0 interface, and another network have 10.1.2/24, which is connected with 0 by 1 interface. So router 1 check here, if user 10.1 trying to share data to 10.1.2.1, so source is here 10.1.1.1 and destination is 10.1.2.1. okay, in this topology. So 10.1.1.1 user forward the traffic to the gateway router, okay, because host always know the gateway device with the IP address of gateway. So gateway is 10.1.1.10 according to the host, and this router check the required parameters. Like, I'm not going into the detail, like at layer 2 error correction and all these things, and check some, okay, and then it will decrement the TTL. So there are a lot of things to discuss, but right now I'm just focusing on the basic thing. So router 1 will check the destination IP address, and destination IP address is associated in routing table with interface F0 by 1. So router 1 check the parameter and complete the layer 2 required information and send the traffic to this particular host. okay, so this is the normal traffic flow whenever all networks are exist in the routing table. But the point is here, if networks are not directly connected with the router, so how router will forward the traffic during that? okay, so you can go through the document. So I have here is another situation. So in this situation, suppose now we have two routers, R1 and R2, and R1 have LAN which have 10.1.1.0/24 network. okay, this is connected with R1 as a LAN 1 network, and R2 have another LAN network which is 10.1.2.0/24. so this is our LAN 2 network connected with R2, and R1 and R2 are connected with the another network with each other at /30. so here is 12.1.1.1 IP, and here is 12.1.1.2 IP. So my question is here, if user 1 is trying to communicate this time with user 3 with 10.1.2.1, so in that case, how traffic will forward or what action will taken by R1 on R2? So normally if we say user 1 want to communicate with user 3, so user 1, okay, create a data packet. Like if you are doing any kind of testing, so it will generate ping packet, okay, ICMP, and in IP header it will keep its own IP address as a source IP address, and destination IP address have target device IP address. okay, and then it should have layer 2 information as well. So it will forward to the router. okay, and now I'm not talking about here ARP and all packet flow. So R1 check routing table, because as we know R1 have only two network information currently in the table. So that is 12 network, and the second one is 10.1.1.0/24 network. But R1 don't have information about 10.1.2.0/24 network. So in this situation R1 is going to drop the traffic, right? So in such type of scenarios we need to use routing. Okay, so routing usually tell us how to forward the traffic from a source to destination, but router need routes in the routing table to forward the traffic. That's why we have to perform here routing. Okay, so need to add routes. Okay, in this situation, so we have two types here to add the route. And what are these two types? So types of routing have static routing and dynamic routing. So today we are going to discuss about static routing only. In static routing, what we can do, we can manually add the routes on a router. And how we can add a static route? So here you can see this is the syntax to add the route: IP route, and here we have to add the network information mask. And after that we have two options to add with the route: next hop either, or we can add the exit interface, right? AD value is something else, we will talk later about it. And now if we check, so R1 have now IP route for R2 LAN network with next hop IP address of R2. So this IP address belongs to R2. Okay, and R2 have network information of R1 with the next hop IP address of R1. So there are two ways: first we can add the next hop, and second we can add the exit interface. Okay, so if I explain you in the diagram, so this is the diagram, right? So you can check the commands. So first we need to add route on R1. So what we are going to add route, so this route we have to add on R1 routing table. So the first option, we can add next hop IP address. So this route we will add on R1, and this is the next hop IP address. That means if R1 want to reach this particular network, so you can reach to this next hop IP address. Why? Because R1 know if I reach on this IP address, this router knows where is the destination network. Okay, so this is the concept of next hop. But at the same time, instead of next hop, we have option to use the exit interface as well. Okay, so in exit interface, what we have to add here, so exit interface is always interface of the same router which giving you exit path toward the destination network. So on R1, if I am adding this route, okay, I have to add this exit interface. So this exit interface also belong to R1. This is the interface, and this interface is giving me a path to reach to R2. So I can or you can say R1 can easily reach to R2 via this interface. Why? Because this is the exit path of R1 to reach this destination network. So we can add any one of them, but both conditions are situational, where we can add. If you check the document, so next hop is always we add at the time of broadcast network. If you know about the broadcast network, like if I'm using here Ethernet cable, okay, broadcast means there can be more IP address or more devices on this segment. So that is the broadcast. So next hop is used for the broadcast, and exit interface is used for point to point network, like before this era, if you know about the serial cable, so serial cable is known as point to point cable, right? So at that time we can use the exit interface. But in both conditions there are some challenges. What are the challenges? If you go through the challenges, then you get to know what we have to do. So if you check, next hop is the IP address of next hop router, which help to reach the destination network, like we discussed already. If R1 want to reach this network, we can use 12.2, which is the IP address of R2. And exit interface is the exit interface of the same router which routes going to be add, right? So like on R1 we want to add some routes, or in this example we have R2, and on R2 we want to add this particular route. And if we are going to add exit interface on R2, so this interface belongs to R2 only. But in both conditions there are some challenges that's going to happen. So that's why we have more solutions for that. And what are the challenges? Let's discuss about it. So the first challenge is with your next hop only. If you add next hop only, like if I'm going to add like this route on R1, so R1 know about the next hop only 12.2. So this is the one entry, and the second entry is here about the directly connected route, and this is the exit interface. So this is the first lookup for R1 to reach this network. But in this entry in routing table, R1 don't have idea about exit interface from where I have to exit. So R1 have to check this entry as well. So that's why router have to take twice lookup in the case of next hop. So that's why next hop is not good. Okay. And if we talk about the exit interface, if we are using broadcast network, so there are chances of proxy ARP. So if you know about the proxy ARP, you will understand the scenario. So these are the two main challenges if we are using individually next hop IP address or exit interface. So that's why we have third option to use fully static route. So fully static route is the combination of both next hop and exit interface. So that is the best thing we can use in static routing. Okay, so this is all about the theory things. So now we can go with the practical scenario. So I have similar topology here, and you can check R1 this interface of 12.1, R2 this interface of 12.2, and this is the virtual PC 10.1, and this is virtual PC 10.1.2.1. okay, and these are the gateways IPs. So I'm starting in this lab with initial, so there is no configuration on any device. So let's start with R1 first of all. The devices are already on. Okay, so these are the Cisco routers. If you check, there is no IP address, so we can start with the IP address interface. Each 0 by 0 is LAN interface, no shutdown it, and add the IP address 10.1/24. Another interface each by 1, which is WAN interface, and 12.1, and here is the subnet mask. If you check, both interfaces have IP address, right? Okay, so we done with the configuration on R1. So now let's configure on R2 as well. Interface it's 0 by 0, which is connected with R1 12.2, and there must be 252.4/30, and interface 0 by 1 for LAN, and here we have IP address 10.1.2.10/24, and to show IP interface brief. So here we can check, here are IP addresses, right? So now if you check routing table of R2, show IP route, so this will only show you, show IP route command will show you we have two routes here. Okay, so the first one is connected 10.1.2.0/24, the LAN network of R2, and the second is 12.1.1.0/30, which is the WAN network. But R2 don't have information about R1 LAN network, right? And similar, if you check on R1, show IP interface brief, these are the IP, and show IP route. So here you can check, it have connected network 10.1.1.0/24 on Ethernet 0 by 0 interface. Okay, and here is 12.1.1/30 on Ethernet E0 by 1. So R1 even don't have idea about this LAN network. Okay, so the point is we have to add the routes manually. But before that, if I'm trying to check you, let's give the IP to the host. So these are the VPC host. Okay, and we can give IP address, I guess. Let's check the command. So how we can give IP 10.1/24, and gateway is like this. Yeah, so you can check, checking for duplicate IP, so there is nothing. And if you check show, Okay, just a minute, IP address is not assigned yet. Yeah, I think I did a mistake on R1. I configured IP address on here and the MAC is conflicting, right? So I need to change here. Change the IP address 10.1.10. Okay, and now let me try to give it again. Checking for duplicate, and now IP address is set. And if you check show IP, here is this IP and this is the gateway. So similar we can give on VPC4. Okay, duplicate. So VPC4 is also checking for the duplicate IP, and here we can see IP address is here. Now if I'm going to try to check, I'm going to send ICMP traffic from VPC3 to VPC4. So I can execute ping command 10.1.2.1. So here we are sending the data, but you can see there is timeout, destination unreachable, right? So that means VPC is not able to reach. If you try to reach to the gateway 10.1.1.10, so we can reach to the gateway successfully, and here you can see we are getting the reply. So we can check that traffic is getting dropped on R1. So what we can do, the first thing we can give static route on R1. So there is always difference in routing table output if you give the next hop or if you give the exit interface. So first of all, we don't have route, so how we can add the route? IP route, and route is this one, and after that subnet mask for it. And now we have two options, like there are many, but I'm talking about the next hop. So here I can add the next hop IP address. So this is the next hop IP address, and the next one is the exit interface. And exit interface I can directly add the Ethernet interface, or maybe it's loopback interface. Okay, so here we have 12.1.1.2. so this is the IP address. And if you check show IP route, so here we have entry with static. On this route we can reach, and this is the next hop, but in this entry we don't have any information about exit interface. So this is the first lookup, and to reach 12.2 it have to look up again, and it will look up to the second entry which have exit interface 0/1. Okay, and similar we can check on R2. So on R2 I can try, I will add through the 10.1. so I'm using here exit interface. So exit interface is 0/0, which is R2 interface. So show IP route, and if you check, here is static route, but it seems like directly connected. So this is the problem, and this directly connected it will give proxy error problem. Okay, so if route is visible as directly connected, so router always starts sending directly ARP request to this particular network. But R2 don't have this network directly connected, it's directly connected with R1 only. So during that, if R2 is getting any traffic for 10.1.1.1, so R2 starts sending ARP request to this PC directly, but R1 have to respond every time. Okay, but this will remain for entire LAN because the network is at /24. So this is the problem. So what we can do here, we can remove this entry, and we can add the fully static route. And fully static route is with exit interface and next hop like this, and show IP route. And now you can check static route is here with this next hop and this exit interface. So this is known as fully static route, and we have added on both routers. And if we try to send traffic, so this time we have successful communication. Okay, so that how you can add the routes. And here we discussed with the topic. So to know more things, please subscribe the channel and share the video and press the bell icon. Thank you.